A very good afternoon to everyone. Welcome in today's class. And in today's class, we are going to talk about phylogenetic trees. That is the topic of. But before moving with the topic of today, let us have a small introduction about an academy. In the beginning, as we say, crack CSIR-UGC NET together. I'm your educator Farida Bandookwala, and I'm pursuing my from School of Biotechnology, ABD. I've done MPhil in biotechnology, qualified and PhD examination, and I have a teaching of 10 months. You are preparing for CSIR NET with an academy. What are the benefits you have? You're going to get daily life classes so that you feel motivated that every day I have my classes, and you'll also feel connected with the course. Then the course is in a very structured manner, it's arranged in a very systematic manner. Otherwise, it's a very lengthy syllabus of 13 units in case of life science. So structured course means you will be able to complete the whole syllabus in a confined time. And there are live tests and quizzes. So what are the benefits of live tests and quizzes is that you can evaluate yourself. Whenever you are going for any kind of competitive examination, it's very important to evaluate yourself that how much you have learned so far. So live tests and quizzes gives that accessibility. And then if you are going for the plus subscription, you will have unlimited access to all the videos recorded under that category. Then Unacademy provides us free live classes. And what are the free live classes? Free live classes are conducted on YouTube, and free live classes are conducted on special platforms. So the class which are conducted on YouTube, you are for now sending the free class of YouTube. So that is like if you can subscribe to our channel, that is let's crack CSIR-UGC NET, and you will be able to get all the free live classes. And then what about the special classes? So special classes are on the platform of our application. So download the app from Play Store, and once you have downloaded the app, you can make your account and you can log in, and you will have access towards all the special classes in whichever category you are going for. So for now, we are doing CSIR-UGC Life Science. You can go for that category. After that, there is this plus subscription. And what are the benefits of plus subscription? All the 13 units in a well-defined, arranged manner in the plus platform. Before all the upcoming exams plus courses, they keep on conducting the crash courses, then short-term courses. All these types of courses are being continuously conducted on the plus subscription. And if you're going for a plus subscription, it is very pocket-friendly amount. It is not at all costly. So if you're going for 12 monthly or 24 monthly, it's very, very cheap. If you're MSc first year student, it will be very much helpful for you to even to study the topics which are there in your curriculum. And definitely it is planned in such a way that you will get all the idea about CSIR-UGC NET examination. So plus subscription helps you over there. And in this plus subscription, if you are using my referral code, that is FP01, you will be getting a 10% discount. So do not forget to use my referral code, that is FP01. Now talking about the topic of today, that is phylogenetic tree. This is the topic of today. So what is a phylogenetic tree? To know the evolutionary line of any organism or of organisms, if a pictorial representation is done in the form of lines, it is called as phylogenetic tree. Why is it called as phylogenetic tree, or why is it called as this tree? Why the tree word is used? Because it appears somewhat like tree structure. Branches would be there, then roots would be there, so it looks like a tree. So it is called as phylogenetic tree. Now if we are going for a literal definition of phylogenetic tree or points which can define phylogenetic tree, so what is a phylogenetic tree? It is a diagram that represents evolutionary relationship amongst the organism. A diagram representing evolutionary relationship amongst organisms. Then it is a diagrammatic representation. So it is the way how we are thinking that evolution would have occurred. It is not actually how it has occurred. We don't know concretely, yes, this has happened, because the way phylogenetic tree is made is not 100% on the basis of experimental data. Some of the things are hypothesis. So it's a hypothesis, it's not a definitive fact. It's a hypothesis, not a definitive fact. The phylogenetic tree is not a fact, but it is a hypothesis given by people. So it is to trace the evolutionary line of an organism. So the pattern of branching in the phylogenetic tree, it reflects how a species or how other groups, they have evolved from a series of common ancestors. So it is like to know that this organism has evolved from this organism, that organism has evolved from that organism. So the pattern of branching in the phylogenetic tree, it tells how the species they are different from others, how much they are similar to each other, where the species they are converging into a common ancestor. These all things we can understand from phylogenetic tree. So the pattern of branching in a phylogenetic tree reflects how species or other groups evolved from a series of common ancestors. This is what our phylogenetic tree tells us. Pattern of branching, that where they are branching, where they are converging, where they are common. These all things we can make out from a phylogenetic tree. Now what else? Is there anything else also that can be done? So yes, phylogenetic tree can be drawn in equivalent styles. So what do we mean by this? That if a tree it is rotated or it is seen from some other direction, the branches they will remain on their place, they are not going to change. So that means rotating a tree about its branch, one would not change the information it carries. The information is going to be same if it is rotated, it is twisted, whatever is done with that tree, the branches, whatever information is there, it will carry it as it is. So rotating a tree about its branch point doesn't change the information. Is the important thing. So you draw it this way, you draw it that way, it is going to tell you the same thing. So these are the basic points which are related to phylogenetic tree which you must know. Now, types of phylogenetic tree. So whenever we are talking about tree, the most important thing is roots are underground, roots are above the ground, like the banyan tree, all these things is the basic thing whenever we talk about the plants. So the first differentiation of phylogenetic tree is rooted phylogenetic tree and unrooted phylogenetic tree. First is rooted phylogenetic tree and second will be unrooted phylogenetic tree. So when the origin of the ancestors of a phylogenetic tree is known, it is called as rooted tree. And when the ancestors of the phylogenetic tree and the organisms of the phylogenetic tree, they are not known, it is called as unrooted tree. So when known organisms, known offsprings, with the known ancestor rooted, because root is known, you can see the root. But if you cannot see the root, you cannot get the root that from where they have originated, simple, the term comes as unrooted. So when origin of ancestors of a phylogenetic tree is known, called as rooted phylogenetic. So how will it look like? It is going to look like this: X, Y, and W. So X is the common X ancestor, and from X, Y, Z, and W we have come. So rooted phylogenetic tree. We know the common ancestor. So it is kind of, this line is kind of a root. So we know the root from where all the organisms they are coming from. When we don't know from where all these organisms are coming from, it is called as unrooted tree. So when origin or ancestor of a phylogenetic tree is not known, called as unrooted phylogenetic tree. So how are we going to draw this unrooted phylogenetic tree? Somewhat like this. So it will be X and Y, Z and W. This is how you draw an unrooted phylogenetic tree. As easy as this. Nothing else. Rooted phylogenetic tree and unrooted phylogenetic tree. Two type of phylogenetic trees you have seen. Now let us talk about um, three other types of terms, that is homologous organs, analogous organs, and then we'll be talking about how the pictures are drawn. So the first thing that we are going to see is homologous organs. Homologous organs. So what are homologous organs in an organism? The functions are different, but the structures are similar. So organs which are structurally similar but functionally different, they are called as homologous organs. This is homologous organs. The structure would be similar, but the function would be altogether different. So origin of characters is same, but due to different environmental condition, they adapted and they developed into some other organ. So origin of characters same, but due to different environmental conditions, their function became different. So they became divergent. Divergent, adaptive, evolution. This is the thing which is related to homologous organs. That origin of the characters are same. The organs, they are similar in its origin. Because of the environmental condition, because of the need of the time, because of the pressure of the selective pressure, they are now divergent in their function. So this is called as divergent adaptive evolution. Divergent adaptive evolution. So this is how we see homologous organs. Now, if we are talking about homologous organs, let us also talk about the examples of homologous organs. So, forelimbs of mammals which are modified into wings for holding the parts, and locomotive organs of some of the mammals, they are the example of homologous organs. So, we can write forelimbs of mammals. Forelimbs of mammals. So how are they? Uh, we'll take another page. Bats, then humans, then cattle, then dolphin. These all they have certain other organ for the locomotion, for movement. So bats, they have got wings, and they have got wings for flying. Humans, we have got fingers for holding. Cattles, they have leg, and they have leg for locomotion. Then dolphin, they have fins, they have fin for swimming. So this is about the homologous organs, right? Now another thing that we need to know is analogous organs. And we have kept some of the questions. We'll be dealing the questions lastly. So next is analogous organs. Analogous organs. So which organs are going to be called as analogous? So they'll be similar in their function but different in origin. So similar in function and different in their origin are the analogous organs. So what we can say that structure evolved independently, but serve same purpose. But they serve same purpose. Now, why is it happening that they are serving the same purpose? Because of the convergent evolution. They are different, but they have to perform the same function, so they are converging into the same line. So this is due to convergent evolution. This is due to convergent evolution. So where due to some of the environmental conditions, similar characters have developed, and similar characters are different in their origin. So example is dolphin, which is a mammal and it can swim, and other is fishes. Fishes, they have also got fins for swimming. So they both are belonging to very different categories. Dolphin belongs to mammals. Fishes there itself belongs to the uh, fishes category. So dolphins and fishes, they are different in their origin, different in their characters, but because of the need of the environment, they are showing similar characters or similar functions. Example of analogous organs. Now another term comes into being. Another term comes into being is homoplasy. Homoplasy. So what is the meaning of homoplasy? When two species, they share a common trait and character, and this trait and character is absent in their ancestor. It is called as homoplasy. When two species share a common trait and character, and this trait or character is absent in their ancestor. This is called as homoplasy. Right? This is the thing. Now, another thing that we need to know is maximum parsimony. Maximum parsimony. So, what is the meaning of maximum parsimony? The meaning of maximum parsimony is the shortest possible phylogenetic tree is the most accepted one. Shortest phylogenetic tree is most favored one also. This is the thing. Now there are certain groups in phylogenetic tree that we should know. So groups in phylogenetic tree. Groups in phylogenetic tree. So first of all, I'll draw a phylogenetic tree and then I'll explain you that how this phylogenetic groups are actually called so. So somewhat like this. This is the case. Now I'll use a highlighter. This portion, first of all, we'll see. So this block, this yellow highlighted block, this block is what is it showing? First of all, we'll write the characters over here, then I'll tell you the name of it. So from what or you can see from here, from in B and C, what you can see, if you are just forgetting about rest of the thing and you are just concentrating on A, B and C, so what you can see say is B and C, they share a common ancestor. So ancestor and descendants in the branch, they can be seen. So in this group you can see the ancestor as well as descendant. Ancestor and descendants. Only this much it is going to tell you. So this type of group is called as monophyletic. Monophyletic group, right? Because you can see ancestor and you can see descendants. Then another thing what you can make is from this. So for this, how can you draw is dollar. Now here what all you can see the ancestors and all the descendants are not included. This ancestor is having over here some of the thing and only one of the descendants of X you can see. So you can see ancestors. Ancestors are included, all the ancestors are included, but descendants are not included. So from here you can write ancestors included, but all descendants not included. So this type of group is called as paraphyletic group. The second type of group. Now we'll make a third type of group from this. So it will be like this. So what you can see from here, very easy to understand, that you can see all the descendants but you cannot see any kind of ancestors. So what you can see here, all descendants but no ancestors. So this type of group is called as polyphyletic group. Called as polyphyletic group. So first is monophyletic, where all the ancestors and all the descendants are there. Second is paraphyletic, where all the ancestors are included but not all the descendants are included. And the third one is polyphyletic, where no ancestor is included, only descendants are included. So now you know homologous organs, you know analogous organs, you know groups in your phylogenetic tree. Now another two things that you need to know that I'm going to tell you, two, three things that you need to know in phylogenetic or phylogenetic analysis is your cladogram. 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 So what is a cladogram? Monophyletic group is called as a clade and a tree made out of all the clades is called as cladogram. So cladogram is a picture or it's a diagram of monophyletic group. Monophyletic group. Cladogram. The diagram of monophyletic group. Now what you can tell from cladogram is which organism came from which organism. But you cannot tell about the timeline, that which one was the first or which one was the second. You can tell the relationship amongst them, but you cannot tell which one came first and that like that. So can't tell the first or last evolution among descendants or ancestors. And shows the ancestral connection between the taxa, but do not tell you anything about the timeline. Shows ancestral connection between taxa, but not based on timeline. So how are you going to make a cladogram? How can you make a cladogram? So cladogram would be very simple. All the lines can be of same length. So if these are the species, they are all originating from a common ancestral species X, and this line is called as clad. Only these lines, they are called as clad, and as a whole this diagram is called as cladogram. Right, so this is how you can see a cladogram. Then you need to see dendogram. So dendogram is always with respect to time. It is just a kind of a phylogenetic tree, but it is always with respect to time. Always with respect time. And how is it always with respect to time? This is a common ancestor changed into another species, and then this species got diverged into some other species. So the length is going to tell you how long did it take. So this is another line of evolution where it evolved like this. So these things, these lines, these are called as internodes. These are called as internodes, and internode length is directly proportional to the time taken for evolution. Internode length directly proportional to time taken for evolution. This is about the internode. Now we'll just make a phylogenetic tree, and we'll just try to name the things, and after that we'll be moving towards the questions which I have included. So like this. A, B, and C. So these are the terminal taxa. These are the internodes. These are the internodes or internal nodes, and the root These are again internodes, and this is the terminal branch. So this is how we are going to see that how the things are, right? So we have almost completed all the basics, and usually questions are asked in this topic. First the question, right? So see here, the question says that species 2 is most closely related to species, which species in 1, 2, 3, and 4 based on the phylogeny shown. So can you see that species 2 and species 3, they're sharing a common ancestor? They are sharing a common ancestor, isn't it? This is the point where they are having a common ancestor. If you are going for any of the species, but if you are going for species number 2 and species number 3, they are very close. They both have the branches of a common stick or a common thing. So these two stems, they are on the same branch. So 2 is most related to 3. Here by mistake I have already highlighted the answer, but otherwise also it will be most related to third species. Now another question is Denisovan. Sorry, the question is over here. Here it is just the answer. So the question is, following is a diagrammatic representation of human evolutionary tree. So you have to tell that in the above diagram which is 1, which is second, which is third, and which is fourth. So can you see that first came first, second came after that, third came after that, and fourth came after that. So they are just asking you the sequence of this thing, nothing else but a simple sequence of the whole organisms they arise. So we know that Homo neanderthalis, it came on the third, and Denisovan, it came near about that. So just to solve these type of questions, we should have a small idea in our mind that which one came first. So this Homo neanderthalis, what is so special about them is their cranial capacity was large and large and large. So in this case, if you are seeing this question that which organism came for the first, if you can guess from the option that what all should have come after each other, if you can see from this picture. So I'm just giving you a minute of time for telling that which is the which is the actual series of evolution, or which is the correct option. So I'm just waiting. I'll just see your comments in the chat box. So yes, if someone is asking many questions, so till then you can just guess that which one could be the right option. So I'm waiting for you all to answer that which one could be the better answer in this case. So I can see very less students answering for this. So I'll just check that what is the right answer. I'll just tell. So we know the first in the series came Homo habilis, and we know that Homo neanderthalis is on the third, and it is quite near to Homo sapien. It is not much away, so the nearer one should be Homo neanderthalis to the Homo sapiens. And Denisovan, we know that it came quite near to the Homo sapiens or after Neanderthalis. So you are not knowing the exact series. Also, if you know some of the things, you can make out. So the answer is B. Then in this question, that based on the above, which one of the following statement is correct? So see from this, group X is monophyletic and group Y is polyphyletic. So monophyletic and polyphyletic and Paraphyletic we have seen. So based on the above, which one of the following statement is correct? It is saying that X is monophyletic and Y is polyphyletic. So monophyletic, it should include all the ancestors and it should include all the descendants. So that is not right. Group X is paraphyletic, and what is paraphyletic? All the descendants are not included. So X in this, all the descendants are included. So X is paraphyletic and group Y is monophyletic. So this is also wrong. Both group X and Y are monophyletic, but you can see in Y that one of the G is excluded out. I'll just take the laser light. You can see that here the G is excluded. And the last one is saying group X is monophyletic. In monophyletic, we know that all the ancestors are included, all the descendants are included. So yes, in group X, all the ancestors are included and all the descendants are included. And Y is paraphyletic. So all the ancestors, they are included, but all the descendants are not included. So G is not included in this case. So this might be true. So yes, in this we can go for the option number D, because X is saying that it is monophyletic and Y is saying paraphyletic. So yes, this is the right answer. And according to the cladogram length shown, which organisms are most closely related? Sorry. So exospermum and Takta Taktagania is closely related. Is it so? So first of all, let's locate this. So this one and this one, they are saying that they are related. So they are quite distant, isn't it? Exospermum and Tasmanian. So they are also quite far. Belliolum and Rubia. Belliolum and Rubia, they are both sharing a very common link. It is in the V form. And if you are going to draw exospermum to Tasmanian, you have to draw very, very long lines, and it is quite far away, and many other things are also coming in between. But when you are seeing Bell, Belliolum and Bubia, you cannot see any other thing interfering in between. So some of the things, they are parallel to this, but at least they both are in a common V. So they are the most closely related, sorry, species. Then Belliolum and Drinus. So this is also not directly in the V. Then Exospermum and Tyrannus, so they are also not directly related. So the most appropriate over here is Belliolum and Rubia. These are the two species which are closely related. Then next, as a biologist, you want to classify three taxa A, B, and C to have the information on traits P, Q, and R. The trait that is ancestral is counted 0, and the trait that is derived is counted as 1. The distribution of traits found in the three taxa is given below. So here A and B. So A is having 1p. Okay, in A they are saying 1p, and in B they are saying P also. In Q and P, they both are common to A and B. Fine. R is there in B, so yes, that is also there. Then for C, they are saying C is having only R. So yes, okay, fine. This can also be okay. Yes, it is fulfilling the condition. Now A and B, they both have got PQ. They both have got PQ, right? Okay, fine. They have got PQ. And C, it doesn't have PQ, but it has R. Okay, right? That is also true. Now the C one. A has got P, but they are not showing Q in this A, and here they are showing P and Q in B. But it is not showing Q over here. But A wants Q also. So this is like 100% wrong. Now the option is either A or either B. So you have to choose from A or B. So what the rule says that you have to select a option which is most closest. This is called as the parsimony principle, the one which is the most closest. So here also, based on the trait distribution and the principle of parsimony, select the correct option. So if you want to select the correct option, and if you are thinking that A and B both are correct, so that in that case the question should not contain the word parsimony. Yes, they are correct, but it is not according to the parsimony principle. According to the parsimony principle, only option B is correct because this is more near. This R, uh, yes, here you can see that B is having R and here also B is having R, or here one more thing is missing, that R is also missing, so this is like wrong. But here you can see that R is included in B and C, and A and B, they both are coming from a common line, that is P and Q that it is having. So the most appropriate in this case would be option number B. Now another question, according to the phylogenetic tree, which organisms are least related to each other evolutionary? Which one are least related? So Trilobita and Insecta. Okay, one they are saying this Trilobita and Insecta. Then it is saying Insecta and Myriapoda. So they both are related, isn't it? If we would have drawn a line like this, slanting line, so they are coming in our that V thing, right? What I was saying, that that is coming from a common thing. So Insecta and Myriapoda, no, no way, is not at all. Then Insecta and Crustacea. So Insecta and Crustacea, they are also quite related to each other as compared to Trilobita. Then Trilobita and Chelicerata. So Trilobita and Cheliceratta. So it is asking which of the following the are least related. So they are both closely related. No, no ways they can be farly. Then Crustacea and Myriapoda, but they are also closely related. So here the answer would be Trilobita and Insecta because they are far, far away. Right? Very easy question, not at all difficult. Then which one of the following tree represents a fully resolved program, phylogram? So can you see one A, B, C, and D? So can you see in the C one that all the descendants they are of equal length? Can you see? So when the descendants they are of equal length, they are not a very good representation like a dendogram. It is not telling you the right information. So C cannot be right at all. And if you are seeing B, here also the length is not varying much. See about this and this, and if you compare this line from here, so it is giving you a clear picture that which one came previous and which one came after. So B is also not correct. Now the option would be between A and D. So you can see here in D and A, if you are going for just this much part, can you see how much resolved the A is? One line is lengthy and one line is small, and here also how much difference in the length is. So this is like fully resolved program as compared to anyone here in the picture. Now, which term best describes a group of species without a common ancestor? If you are saying a group of species without a common ancestor, they are polyphyletic, monophyletic, paraphyletic. So what are they? They are not having any kind of common ancestor and they are seen together. So what are they? They are polyphyletic. We are seeing species and we are not talking about their ancestors, no ancestors, but only descendants. So it is polyphyletic. So yes, this is how we have completed our topic of phylogenetic tree. So I hope you people have understood this topic in detailed manner and now you are well equipped to solve the questions, because mostly you won't be asked to try to draw a cladogram or a dendogram or a phylogenetic tree. No, no, that way CSIR is not going to ask you. They are going to give the questions which just we have done. If you are able to solve those questions, good enough, you can do it. And if not, you can go through the video as many number of times as you want to so that you can understand the matter. And lastly, thank you for your patient listening. And as we say, let's crack CSIR-UGC NET together. Please hit the bell icon for getting all the notifications of the upcoming videos and subscribe our channel, that is Let's Crack CSIR-UGC NET. And please like my video if you really like the content and understood the fact. And lastly, do not forget to use my referral code FB01 for getting a 10% discount. So do not forget to use my referral code, that is FB01. And lastly, if you want to study any of the topic from the 13 units of CSIR life science, you can write in the comment box over here that whichever unit you want to discuss with me or you want me to explain to you, or any particular topic, you can write in the comment box. Whenever I'll be going through my videos, I'll just check the comments and try to come in the class live, because there you can ask your doubts and queries live with me. So I'll be very much happy to see you live in the class and participating in the various question and answers which we do in the class. So this is it for now, and we'll be meeting in another class that is about the spontaneity of the mutation. This is the topic which we are going to talk in the next class. So for now, it's a bye from my side, and hope you people are studying and preparing well for the upcoming CSIR-UGC NET examination. So keep on studying and be happy, and come back for another class and write all your doubts and queries and whatever you want to ask me in the comment box. This is it for now. It's bye.